All right, let's take a look at 14.73, Part C and Part D. Part C presents a lot of challenges. First, you're making a solution by dilution. Then, you're given a base instead of an acid. So let's take a look here. In order to solve this problem, I'm going to follow a couple easy steps. First, I'm going to calculate my new concentration in the dilute solution, so I'm calling it MD, the dilute solution of barium hydroxide. Once I have that, I'll be able to calculate the molarity of my hydroxide. With that, I'll be able to calculate my pOH, and for my pOH, I'll calculate my pH. So let's execute. Remember, MdVd, the molarity of the dilute times the volume of the dilute, equals the molarity of the concentrated times the volume of the concentrated used to make it. So in this scenario, we have 7.6 times 10 to the negative second molar times a volume of 39.5 milliliters equals to a molarity that we're wanting to solve for times a volume of 289 milliliters. So, perform a little algebra. 7.6 times 10 to the negative second times 39.5 milliliters divided by 289 milliliters equals my MD equals, and that formula should be one you remember from 170. Molarity of the dilute times the volume of the dilute equals the molarity of the concentrate. Oh, actually, I reviewed it for you at the beginning of the semester because it's so important to what you do this semester. 7.6 second EE negative 2 times 39.5 divide by 289. So the molarity of your dilute solution is going to be 0.01039 molar barium hydroxide. So now we have the molarity of our barium hydroxide. That's just the beginning. That's just the answer to step 1. We have to calculate the molarity of our hydroxide next. For every formula unit of barium hydroxide I produce 2 hydroxides when I dissolve it in water. So if I have a concentration of 0.1039 molar barium hydroxide, then I have 1 mole of barium hydroxide to 2 moles of hydroxide equals a concentration of hydroxide of 0.02078 molar. So that's my concentration of hydroxide. So now I want to solve for my pOH. My pOH is equal to the negative log of my hydroxide ion concentration. which gives me 1.68 2 as my POH. Now that I have my POH, I can solve for my pH, because pH plus POH equals 14. So pH plus 1.682 equals 14. So pH equals 12.318. So that's what I get my pH as. They say to 2 decimal places, so 12.32. All right, now let's try another one. Let's try part D now. Part D, they're playing again on the dilution factor. They're telling you that you're mixing equal volumes of 2 different strong acids. Now, both of these acids, hydrochloric and nitric, can only give 1 proton. So they've simplified it for us. In other words, chemically, these guys are going to behave the exact same. Both strong acids, both going to give off 1 proton. So really, it boils down to simply averaging the molarities. We're told that we're mixing equal volumes, right? So let's just set up a little thing here. The molarity of the new solution is going to be equal to the molarity of HCl times volume X plus the molarity of nitric times the volume of X. Why? What am I doing right here? Molarity times volume gives you moles, right? So that would be my moles of hydrochloric acid. That would give me my moles of nitric acid by multiplying molarity times the volume. And then my new volume, so what I'm doing is I've got that term up there, molarity of hydrochloric acid, molarity of nitric acid. Not molarity, sorry. Moles times volume. Molarity times volume is moles. So I've got my moles of hydrochloric acid with this term. Molarity times volume is moles. So I have my moles of nitric acid right here. If I add these two together, then I've got my total moles of acid. So I have my total, I need a new color there, that blue's not going to work. I need my total, so I have my total moles of acids in my top term. Well, to get my new molarity, I have to divide my total moles by my total volume, or my totally new volume. Well, since I'm using the same amount of each, then my new volume is going to be Vx plus Vx, or Vx2, right? Vx plus Vx is 2Vx. So I have 2Vx over the molarity of my hydrochloric acid plus the molarity of my nitric acid, and I can pull out that Vx there, right? Pulled the Vx out of parentheses, and now the Vx cancels out, so my molarity is simply the average of the two molarities, since I'm using equal volume. So let's do it and get my molarity here. So my new molarity is 0.25 plus 0.59 divided by 2. 0.25 plus 0.59 divided by 2. And that gives me a molarity of my acid solution. Oh, the answer to the life, universe, and everything in it. Somebody's a Douglas Adams fan. Gives me that as my concentration of acid. And since they're both strong acids, to get my pH, it's simply going to be the negative log of 0.42, which is going to be a really low pH. It is. Dang. The pH is 0.38. That is really low. But that's your answer, and that's it. Beep.